So, good morning and welcome once again to Chai and Y from the Ruparel College in Matunga on the third Sunday of the month. I hope you can hear us. And with us today is Kunika Gupta from the Department of Chemical Sciences at TIFR. And we are going to be talking about colors because this is our Holi special. You've all celebrated Holi just probably 2 days ago. This is the nearest Sunday. And as traditional, our Chai and Y in the middle of the month, the nearest Sunday to Holi is always about color. And we're going to have Kunika take us about the world of color from a chemistry lab. So if you can look at the table, can you just maybe tilt this towards the table? And if you look at the table, we've got lots and lots of nice colors. And I guess she's going to show us lots of experiments. And we're going to take it from there. So I must also acknowledge that Kunika has got a lot of help from your colleagues. You'll introduce them sometime. You'll call them and introduce them. Okay. So Kunika is a which year student? Third year student at I think we are at the Department of Chemical Sciences in Professor Rampuna's group. Where she works on synthesizing all kinds of molecules that she will tell you about. She comes from Ghaziabad and joined us here for a PhD. So over to you. You can introduce yourself. You can call your friends, introduce them. We'll be helping you, and we will take over. Now, one thing is, if you're watching us live, if you're watching us online on Zoom or on YouTube, we would like it if you can just put in your questions and comments on chat, because that's the only way we know whether you can see us, whether you can hear us, whether we will ask you a few questions. So please be interactive and ask your question. Of course, you will not get chat. Beyond that, let's get started. Okay, yeah. Yours. I'm going to go back and control the camera.
Yeah, thank you, Arnav, for introducing me. So I could go about by acknowledging people who have made it possible till here. So yeah, thanks to the Chai and Y team for giving me this opportunity, and my friends. So I would like them to call on the camera. Suman, Komal, who have helped me set up everything, like pack up and bring it up here. Pradeep, who has been an audience, like who has come all the way from TIFR to Matunga to watch the session live from here. So Pradeep, you can also be on the stage. Yeah, so this is my TIFR people who have supported me in organizing this event. So yeah, let's get started. So yeah, it's good to see a few people live in the auditorium, and yeah, mostly on the Zoom session. So yeah, let's start the colorful Holi session. So we'll go about by starting what is color, or if you ask, what is light? So light is something which is like a wave, right? You know, it's something like a wave. But you don't see a light wave, but you must have seen a water wave when you throw a pebble into a stream of water. How does it go about going? It goes about going like this. And a difference from this to this is known as a wavelength. So one time in which the amount of these waves pass a point is known as the frequency. And corresponding to those frequencies, we have color. So if you can see from this CD, so we have only white light in this room, but you can see that there are different colors coming out of it, right? So why is it so? So it is because the white light is not actually the white light. It has multiple components into it, which just split once they are in contact with something, which can split into its components. So here we have one CD, which is actually splitting the white light into its different colors. And why is it happening? Because the light is actually a wide electromagnetic spectrum, where you have the microwaves, radio waves, X-rays, visible, UV. And you must have heard a few of the words which I am speaking, like the radio waves in the remote controls that you have for your TVs, the microwave, where you cook your food or reheat your food. Then IRs, you are all acquainted with the IRs, the heating guns that you see in the malls or anywhere you go, that works on IR. Then comes the visible spectrum, the one we are seeing here. And then there's an X-ray, which you get once you go to an orthopedics or something, like you have a bone injury or like that. So it's a wide spectrum of light, but we deal with the visible ones because we can see those colors. So this is the one which we are seeing, that once the white light is striking into it, it is giving the different colors and we are able to see it. Now, because the session is all about the colors from my lab, so I'll show you here the different colors that we have. So I'll tilt the camera. Okay, is it fine?
Wait.
Okay.
You want to use which color? This one?
These.
You want to use this? Okay.
Or do you want me to
just bring the bottles in? Bring the vials in front of it and turn it by 90 degrees, and I will switch to that camera.
just Okay, yeah. Now you can see the different colors of the chemical compounds that I have got from my lab. So you see here, this is sodium carbonate, this is calcium chloride, then you have nickel sulfate, ferrous sulfate, potassium dichromate, this is copper sulfate, this is cobalt sulfate, this is ferrous sulfate. So all of these are actually different color. Now, why do we have these different colored stuffs in my lab? Or I should ask, why are they differently colored? So what happens is, these colors are because of some transitions. So I'll tell you this using an analogy. Let's say you live in a multi-story building, okay? But do you ever find yourself roaming around just up and down the lift for no reason? Like, you won't do that, right? So you live on, let's say, third floor. Your relatives are on seventh floor. So you have one particular transition from third to seventh floor, which is very frequent, right? And all the other people living in the building will see you only going from third to seventh, seventh to third, third to seventh, seventh to third. And that is what is particular for you, right? But let's say I have a neighbor whose relatives live on the fifth floor. So they will go from third to fifth, third to fifth. And I'm going from, I forgot on which floor I live. So, okay, so third to seventh. So these are the transitions which people are seeing. And so is with these colors. Their relatives live on the different floors, and so they are transitioning from different states. And corresponding to these levels, like third to seventh, third to fifth, there are different colors. And hence we see a range of colors in my lab. Now, what do these colors depend on? Like, if I have, let's say, copper sulfate, will it remain blue every time? Or if I have this potassium dichromate, will it be orange always? So I'll show you how I can change the color of these compounds and what significance I have out of it. Like, is it just for fun I am doing? Ki haan, mujhe rang badalna hai? Or I am making some sense out of it. So I have this cobalt sulfate. Okay, I'm not seeing the camera yet. So this is cobalt sulfate. You see, this is a pink colored thing. Something.
Wait,
pink.
one sec. Wait,
yeah.
You have to tell me to change.
Okay.
Yes. Now you have. You're on the other camera.
I'm on this camera, right?
Yeah.
Yeah. So now if you see, this is the pink, or let's say light orangish color compound. So now I'll dissolve it and let you, and I'll ask you what actually this is. Okay, so I have a few spatulas. These are not the ones which we use in lab. I just got this for the event. So I take a little amount of this copper sulfate. Then I'll dissolve it in water.
Okay, wait, I'll just go back to this camera.
Yeah, it will be extra.
I'll put both cameras.
Is the color visible on the camera? The audience here can see, right? It's
yes, and I think it's quite visible. You're holding it against your lab coat, and it's quite it's visible that it's pink. Yeah. Audience, I mean, can you see online audience? Can you make out that it's a pink color?
Yeah, so here it is. Okay, so now I'll show you whether can I change the color of this compound. Okay, so I'll take a dropper and I'll start adding HCl to it. So if the audience, someone can say what HCl is. Sorry, hydrochloric acid. So I am adding an acid to it. So it's a strong acid. It's giving fumes. So yeah, so I am on this camera, right?
Yeah, I'll just turn on both cameras. Hang on. Okay. That we can zoom in. Just give me a second. Wait, just wait. Let me just see if I can adjust it so we can get this camera. Yeah, okay. I think we have this as a close-up camera as well.
Yeah, so I hope things are visible.
Yeah.
Right? So you see a pink colored stuff in my hand. Now I'll try to see if I can change the color, and then I'll tell you what purpose is it I am solving to actually what purpose it will solve for me if I know that I can change the color of this. So this is cobalt sulfate, which I have dissolved in water. Okay. So now I will add HCl to it and see if there's some change. So can you see something happening in this? Like the audience here, do you see? Yes. So the audience here says that we see a blue color appearing. I have to concentrate it even more. Now you see, right? So I'll concentrate it even more.
Okay, the online audience also says yes, they can see it's turning blue.
So now it has turned from this pink to blue. And now as I am here, so I can just touch and say that this is an exothermic reaction. I am feeling that the test tube is hot and you have to trust me. Okay. So this is an exothermic reaction, and here you can see a change, a color change from pink to blue. So yeah, it's a lot of fun seeing the color change, but what purpose will it solve for me? And why is that change, first of all? So cobalt, actually, when it was dissolved, when it was normal, so you can see it was orange in color. It was surrounded by sulfates. So it's an octahedral geometry, what you call. So octahedral is like, I would say, this, and this. Okay, so you have six things where you have 6 sites where you have ligands attached. So this, and this. Now when I dissolved it in water, these sulfates, they were like the cobalt got surrounded with water and it was pink in color. Now when I added HCl to it, what happened? That these neighboring ligands, they were changed from sulfate to chloride. So you can see the structures on board. Like if we can we zoom in there? I think it is visible from this camera. This camera, I think this is pretty clear.
If you move out, I can try on this camera also.
Oh, yeah. So the structure is like this, but now on adding the chlorine, it has changed to a tetrahedral structure. So for the audience who cannot see on what is drawn on the board, I'll try to pretend like, so this is this, 2 angles, and the other 2 are like this. So these remain constant and these 2. So now the chloride, the structure of the cobalt sulfate is actually changed from octahedral to tetrahedral. Moreover, from water, the chloride remains. So that is why we see this change in the color from pink to blue. Now, what purpose is it going to solve in my practical life? सिर्फ color change करके क्या मिलेगा? So what we do is कि कुछ जगहों पर we need absolutely dry conditions, like for some reactions or the gas pipelines. So there, what I can do is I can fill the stuff with cobalt chloride. Okay. So I know cobalt chloride is blue in color. But as the water vapors will pass through it, it will start turning to pink. And that will tell me that yes, this has been changed to water. Okay, so that time that is an indicator. It acts as an indicator that the color is being changed. Do you understand?
Yeah, so there's one question wondering why the color changed. Is it because the neighbors changed?
Yeah, that's exactly what I told. That yes, that initially the cobalt was surrounded with water, but that was in an octahedral geometry. And now when I added chlorine, the neighbors changed from water to chlorine, and it was a change in structure as well, like from octahedral to tetrahedral. And that is why we observe a change.
Does tetrahedral mean like a pyramid?
Exactly. So what I showed you is when you join these points like these and these points, you will see that a pyramid is being formed. Okay.
So the color depends both on the shape and who the neighbors are.
Exactly. So these are the 2 factors which I talked about in this particular experiment. Yes, but you have to dilute it much more because I have added a concentrated acid into it. And if you saw when initially I opened this bottle, that there were a lot of fumes. So it's highly concentrated. Okay, so but yes, as I told you, this reaction is exothermic in nature. So if I put it in ice, it should go back. Okay, so I'll do that experiment and show you guys. Okay, yeah, take the camera. No. So I have a little bit of ice remaining. I see if it goes back. So we will put it in this and for a while because I don't think that it's gonna work, but still.
That's a big lump of. Okay, I think now we can go back to this.
Yes. So now this is one of the experiments that I can show you. Then the other
One
is
sec, we'll just show them the fact that you put this.
okay, yeah. This. Yeah.
So
Now as it seen, so I have put a piece of ice and I put this thing into it. So because it's a chunk and not crushed ice, I don't think that it's gonna work. But still I'll keep it for a while and see if it actually does. Okay, so this is one of the experiments. Then the other one is the copper sulfate. So here I have is copper sulfate. Now you can see that it is blue in color. So copper sulfate is actually also surrounded by water, which gives it a blue color. But now if I heat it, what do you expect to happen? So one which is very obvious thing is that when you heat, the water will evaporate, right? So what actual turn I will see in this compound when the water evaporates is what I need to see. Okay, so I'll put some amount of this, not the entire thing because it's too much.
Okay, wait. Now, are you going to do it on?
Yes, because I'm going to heat it.
You're going to heat it. Okay, so let us do one thing. Let's bring this here.
Don't touch it.
Yeah.
Okay, so we'll keep this also for a while, and meanwhile I'll do the other experiments. Okay. So you can see it clearly, that it's pure blue, nothing else, we'll keep it for heating, and this one is for cooling, which I don't see anything happening, but still let's wait. Okay, so the thing is what I do in my lab. So our lab specializes in synthesizing molecules to detect any bioanalyte of interest. So what are these? So we aim to develop sensors to detect the metal ions which are present in the body. So like you have gone for iron test, calcium test, different tests they are available. So how do they detect all these, how do they detect a specific ion amongst all the different ions that are present in your body? So there has to be a specific ligand, or there has to be a specific binding site which will actually go and bind to one metal ion which you want to detect. ऐसा नहीं कि कुछ भी पकड़ के लेकर ठीक है? Because that is what my aim is. So let's say a kid gets kidnapped. अभी तुम उसका फोटो दिखा के भेजोगे ना कि just go and pick this kid. किसी को भी उठा के लाने से doesn't work for me. So that is what our aim is. So we design a scaffold which has to be so specific to the metal of my interest that वो किसी और चीज को it doesn't bind to that. And how will I know whether it is bound or not? अभी if I send a person to fetch me a kid, अभी वो चला गया और वापस ही नहीं आया. How will I know that the person has, whether he has got the person, like the kid I have asked him to bring, or he has never met the person? So I should get a signal as well, like a phone call आए, message आए, वो खुद लेकर आ जाए. So the sensor we designed have two units. So one is a receptor unit which will go and bind to a metal ion of interest, and is a reporter unit which will respond to me कि हाँ मैंने पकड़ लिया. Fine. So the reporter unit which we designed is a dye. So it is a dye. जब metal नहीं पकड़ा है, so it will remain in quench form. और जब पकड़ लिया है, so it will remain in a turn on state. So I'll see a fluorescence out of it. So I'll show you a small demo of the dye, not the scaffold, because that is something which we have to synthesize like very specifically. Because in our lab we aim to detect the manganese ions in a live cell, in a living world. So I'll show you an experiment with the dye. Okay, so how that works. So I'll take an empty test tube. Again, I'll shift the camera. Okay.
Wait. So let's see. Anything is happening.
Yeah, it's happening.
It's happening very slowly. I think you should put it a very small pixel.
Yeah. So if I show you the bottom.
It's not may not focus. Let it heat slowly. Let it heat.
Yeah.
Let it heat. And,
so if you can see there's slight change where the test tube is actually touching. Yeah. So where the test tube is actually touching the ice, it has shifted to pink because it's not crushed ice. Now, the test tube is not dipped into it. Okay. So the reaction is actually reversible. So this is one factor which can reverse a reaction. This is a reversible reaction. Okay. So we have still kept the copper sulfate on the heating mantle. So it will heat for a while, and then I'll show you what change is happening there. Okay. So regarding the dye part, I'll show you the experiment. Is it okay or no?
Yeah. Fine.
Yeah.
So this will require some time.
Yeah, the copper sulfate will require some time because there's lots of water which is absorbed. Okay. And if I focus a bit,
Well, you want to?
I can show you that there are droplets.
Won't focus like that.
Okay, I have to do that.
1 minute. So you can probably say that the glass is not clear because
Yeah,
of water.
the glass has actually water vapors condensed on it because the heating is happening actually inside, and which is the water vapors which are.
Can't we put it on this a little bit?
We can try.
Yeah, let's just try putting it on this. Yeah. Okay.
It's also here.
This one. So what we have done is we've actually just kept the powder on a larger plate which has larger surface area, so the water can evaporate quicker. Okay.
Yeah, so we'll keep this for a while and then let's do the next experiment. Or should
Yeah. Okay. Let's do the next experiment.
Yeah. So I'll show you how a dye actually remains in quenched and a turned on state. So here I'm doing with a simple metal ion, which is a proton. Okay. So I'll take fluorescein as the dye. So here I have fluorescein. So I think you must have heard of fluorescein as a dye. If not, then I'll show you. So this is a dye, which is fluorescein. I will dissolve it in an organic solvent. So what color do you see out of it? The live audience as well as the one in the auditorium. It's red. It's red, right? It's something red. So now you see, and I have a UV lamp here. So I talked to you about the electromagnetic spectrum, right? So we have lots of things. So UV you generally don't use like for a normal purpose because it's harmful. Like obviously X-ray is also harmful, so you're not like allowed to stay in the X-ray room for a long time. Yeah. So here is the lamp. So it's on, I guess. Yes. So here, can you see anything happening in the UV lamp? The lamp is turned on.
Yeah, but we can't. You want to see the lamp?
Yeah.
Then you have to show the lamp, but you can't see the lamp because it's UV.
Yes.
Okay.
So you don't see any light coming out of it. But yeah, the lamp is being turned on. Okay. So you have to like you don't see anything. Okay, let me just check if it is working or not. No, this is not turned on.
It's not turned on. No.
Oh yeah, it's fine.
Yeah. Okay.
Okay, so this is something. So this was the one which I actually dissolved. So now, if you see,
We are out of the view of the camera.
Yeah. Yeah. So now you see the light being turned on, but you don't see anything in my test tube. Okay, no light, nothing. But you see the light here. But fine. Now I'll turn off the light. So this is the dye in the quenched state. You do not see any light. So in the UV range, in the normal, like if you see here, directly you can see a red color, but under UV you don't see anything. Okay. So now I'll add a metal and see if it detects it, if it gets turned on. Okay. So again, I'm taking the HCl as an acid. Here I could have taken anything because I just want protons. Okay, H positive ions. Can you see any color change? So actually the thing is that I have dissolved the initial thing in DCM, that is dichloromethane, and now I am adding sodium hydroxide, which is dissolved in water. So you see a two-layer formation, which I explain you later in my experiments. So if it had been ethanol or methanol, which I forgot to bring, so because it's a live session and we are doing it after a long time, and I would say logistic issues. So yeah. So now if I turn on the UV lamp, yeah. Right? Now, if I turn on the UV lamp, okay, the light is fluctuating.
There is no light. It's not on. Right?
Yes. Okay. So do you see any fluorescence here?
Not yet, but
it's there in the iron.
Yeah.
So this is a color change which you are seeing, that it has just turned to yellow. So niche wala cheese if it has dissolved, so it could have been yellow, but it's like that. So you got my point. So you do not see anything still in the UV. Now what I will do is I add a base. So Do you know what a base is? Anyone? What is a base? Do we have any answers on
Somebody
it?
said it's an alkali.
Okay, that's great. Something like some more answers. Do we have anything? Okay, so now I'll add base to it. Okay, so now see, let's see what happens. You see, there was a spillage because that's an acid base reaction. It's not connection. Okay. So do you see anything now? Something glowing? Not yet, right? Yeah. That's because we have mixed a lot of stuff together. Yes. So now do you see the fluorescence? Just be a bit quick क्योंकि ये चला जाएगा. It's resolved in DCF. दिख रहा है? पढ़ना?
Something glowed yellow.
Yes. If I take it out of the UV, you see it orange. If I take it under UV, you see it yellow. You see? दिख रहा है क्या मुझे क्योंकि I am not.
Yeah. Just put it up. Yep, that's correct. Yeah,
दिख
you
रहा
can see
है?
it yellow.
For the audience, hear this. Okay? And here I'm showing this. Fine. Now I explain you what actually has happened. So I dissolved fluorescein in water. It was not active. It was in quenched form. Okay. When I added acid to it, it was still like that. But when I added base to it, it gave me a turn on response. So means fluorescein is a dye which is active or which fluoresces in the presence of base and not in the presence of an acid. So what I can detect from it is an acid and a base difference. So how is this dye helping me out? So just to give you a relevance of what we do in lab is, okay, if like you take for cancer strategy, cancer treatment. So what we want to do in a cancer treatment is, so cancer is what? There are cells which are dividing on their own in an uncontrolled fashion. So cells do divide. We grow, that's how. Because the cells divide. But if they start dividing uncontrollably, so I can't stop them. So they'll form tumors. So what the therapies that go for cancer is, they go and kill the cancer cells. But if you know about the chemotherapeutic and the radiotherapeutic treatments, what they are doing is they are not only going and killing the cancer cells, they are also killing the normal cells. And out of that, you get so many side effects like hair fall, nausea, and like there are a lot many side effects that the actual treatment that goes on. So here, if I take fluorescein and cancer for cancer cell, it is known that cancer cells are highly acidic in nature. So if I add fluorescein to a group of cells which have cancer and healthy cells, so what you can see is the cancer cells will not glow and the rest of the cells will start glowing. Because I know that the cancer cells are acidic in nature and the rest of the cells are more or less at pH, at neutral pH, 7.7. Okay, so this is just a very basic example. So it's not I just want to glow them in colors. I want something which has to be very specific that goes and only hits the cancer cell. Okay, so here is one way which we are doing it, because our aim is just to detect the ions in the cell. So what we have is a scaffold which is attached to a dye which will remain initially in the quenched form. And when you add it to this group of cells, it will only give me a turn on response when it detects the molecule. Okay, that's the basic stuff. So here we have learned about acid and base. So what actually an acid and base is? So let's say we have a bank. We all have a bank, right? In our states, countries, whatever. So what we deposit there is money. But in a pH bank, what happens is all you can deposit is a proton or a hydroxide ion. So if something which donates a proton or gives a proton to a bank is called an acid, and the one which gives a hydroxide to a bank is called a base. Because our bank में क्या होता है? Like somebody deposits money, somebody takes a loan. So it's something sort of that. But there are two people, one is depositing proton, the other is depositing hydroxide. So the one which deposits proton is called an acid, the one which deposits a hydroxide is a base. So the one which deposits hydroxide, it actually can take the protons. Okay, that is also a base. So it's basically a depositor and a lone bearer. Okay. So how can we do that apart from fluorescein? Like this is something, a complicated thing which I told you, a cancer strategy, a molecule detection strategy. How else can we do that? Before going to that, I'll show you here that the copper sulfate, which I have kept for heating, has actually turned to white. And it was constantly on a heating mantle being heated. So now you see here that the copper sulfate which I have kept in here has turned to white. So for the online audience, oh yeah, who were not seeing it for the entire time, trust me, it was there on the heating mantle, and I have not changed this out. Okay, and the vial, the initial stock, you can see in it that there are water droplets on it which have actually evaporated, and even the surface here has turned white. Okay, so this is how the environment of a salt, of a metal ion actually changes. Because if there are different neighbors, like I told you in analogy, right? You live on third floor, your relatives live on seventh floor. But now if they meet friends, if your seventh floor wala relative starts going to eighth floor, you will also start going to the eighth floor. So that's what something has happened on meeting a new neighbor. Okay. So some simple experiments which can show you the pH change. So one I will take from here. So now switching the camera. You see here, right, a vessel. I add water to it.
Wait. 1 minute, 1 minute. We are getting blocked by all this. So why don't we keep this somewhere here? Yeah, okay. Maybe here. Okay.
Fine.
One second, I'll just adjust the camera. Yeah, go ahead, add the water.
Okay, so now I am adding water to this cylindrical flask. Okay. Now I'll add an indicator to it. So you know what an indicator is? So in general thing, indicator is something which will indicate something. Here I have a pH indicator which will tell me the amount of acids or bases we have, like a balance sheet of an account. Okay, where you will know ki kitna jama hua, kitna gaya. So this will tell me the actual amount of protons in it. If there is an acid, there is a base. Acid will donate protons, base will take the protons. Kuch amount bachega. Abhi wo kya bacha, that will be told to me by an indicator. Abhi indicator kaise batayega? Balance sheet mein I see a number. Here also you see a pH scale. So I'll show you in the camera that there's a pH scale. There are different colors corresponding to that, which will tell me what pH are we actually on. So pH is actually a logarithmic scale of the number of proton ions that we have in the solution. Okay, so it's visible, right? That there is a pH corresponding to a color. Okay, so now I'll add some amount of this indicator in the water that I have added. So what color do you see now? Anyone? Green. So let us see what is the pH for it. So here it shows me a pH 8.5. Okay, somewhere around 8.5. Now for the online audience, you see here, this is something here around 8.5 to 9. Okay, in this range. Now what I'll do is I'll add dry ice to this. Now what is a dry ice?
You want to first make it more alkaline?
I think it's fine. Or you want? Okay.
Put a drop of sodium hydroxide.
Okay, I can add a bit of sodium hydroxide just to show you that this thing will change the color. So you have seen sodium hydroxide ka effect on the fluorescein. If I show you that this also changes the color, you will be convinced enough that the universal indicator, this indicator is showing me the amount of acid and base. So I added a drop of has turned to blue. So now the pH has been taken towards the base side. Okay. Now if I show you the indicator my value, so it is now at 9.5.
It's very dark on screen. You want to add some more water to it? Very concentrated. Very dark.
Is it better?
Yeah, much better, much better.
Okay, so the indicator bottle tells me that it is at a pH of 9.5. Now it should give me a change when they are put on inside. So it will be shifted to the acidic side. Okay, so how I am going to do it? So I will add dry ice to it. So what is a dry ice? So ice is normal thing. Ye wala ice is water solidified. Okay, dry ice is carbon dioxide solidified. So why do we need it? Because ice, if you know, the temperature only goes till 0 degrees. But if I want to go to a much lower value, we need something else, right? So for that we have dry ice. And dry ice, as I said, is solidified carbon dioxide. Okay. So now when I add carbon dioxide to it, let's first see what happens and then I'll give you an explanation. Fine. So do we have any online questions and something?
Not yet. Let me just check. No, nothing on YouTube. Keep going.
Okay, so on the side.
Oh, yeah.
Okay, so here I have is a dry ice. Okay, so अभी नहीं ठीक है so okay, so now you see how it is fuming.
Yeah, it should show us
I'm showing here. So you see how it is fuming here. Okay, ice तो ऐसा नहीं करता है. Ice does not do like this, but there are fumes, but इतना नहीं होता है, right? It's glowing like an agarbatti. Okay, so why is it happening? Because the temperature difference between the dry ice temperature and the room temperature is much more than what the difference is in a normal ice, because it is from 0 to 25. Here the dry ice is something around minus 70, minus 70, some
78.
minus 78. So you see how much a difference here. उसकी वजह से the condensation is much faster. Okay, so now I will drop a thing here. Let's see if it doesn't spill. Okay, so I can't even hold it in my hand. जैसे ice पकड़ सकते हो, इसको ऐसे नहीं पकड़ सकते, because it will give you literally cold burns. और ऐसा होता है हम लोगों के साथ अक्सर. So do you see a color change happening instantly? So it went from green and now it switched to yellow. Okay, so if I read on the pH, this scale, it has gone to a pH of 6 and now it is moving to 5.5. So why has it happened? Like carbon dioxide ने क्या कर दिया? Okay, so carbon dioxide is something which when dissolved in water gives you carbonic acid, which is H2CO3. And it's a very mild acid. इसीलिए ये 4.54 तक है. अगर कोई बहुत strong acid मिलता, like if the result would have been a very strong acid, then the pH would have gone much lower. But it does not. अभी what practical application can I find out of it that I can mix carbon dioxide in water to form carbonic acid? So what we do actually is there are something called incubators. And what incubator is? कि अभी मैं molecule बना दिया. Let's say I have a molecule which can detect the metal ion inside. In the cubate, अभी मैं ऐसे तो नहीं है सीधा लेकर animal model में घुस जाऊंगी. So what we do is we take samples like these salts we take in water. If I have made a sensor for manganese, let's say. So what I'll do is here I'll take manganese का solution. I'll add my sensor and again I'll see in the UV if I see a turn on. Like if I see a fluorescence out of it. ठीक है? So what actually should happen is कि जितने भी मैं salts दे रही हूँ, only the manganese should give me a turn on response, nothing else, because जो ligand है वो तो मेरा जाकर chelator है, मतलब whatever this binding thing is, it is actually going and binding to the manganese. Fine. तो मैंने टेस्ट ट्यूब में चेक करा काम कर रहा है. अभी इसमें सिर्फ मैंगनीज था इसलिए काम कर रहा है. क्या ये एक सेल के अंदर काम करेगा? Where we have lots of ions present. Like in your body you have calcium, iron, manganese, cobalt, copper. And not only ions, they are in the different oxidation states, +2, +3, +5, कुछ भी चल रहा है. So whether my sensor is going to detect it, तो उसके लिए हम क्या करते हैं?
Want to just add some sodium hydroxide and see if this happens again?
Sure, I can do it for you.
Just add something and let's see if we can do this color change one more time. There we go. Blue.
So it has gone again blue. So there is a chunk of dye still there inside, because of which it is fuming. So now you'll see a
Blue is
color
becoming
change
light blue.
to green.
Light blue. Light blue is turning greenish. Greenish.
Now it's shifting to yellow.
And it will slowly go back to yellow.
Okay. Yeah. So I have tested in a test tube कि हाँ भाई metal ion तो detect कर रहा है. But inside a cell where I have lots of ions, whether this thing is gonna work or not. अभी if I have taken out the cell out of my body, तो cells कैसे जिएंगे? If you like एक skin का एक normal piece, if you remove from your skin, like ऐसे skin का छोटा piece, you'll see instantly it dries up. It's no more moist as it is on your body, right? So how am I going to make these cells survive? Okay, so cells need an optimum pH. बहुत कुछ चाहिए होता है. I'm just talking about a factor of pH. So how are we going to control a pH in a cell which is out of my body? Okay, so उसको जो pH चाहिए होता है, we use this particular technique. We put them inside an incubator which is supplied with a carbon dioxide. The cells are in a media, मतलब कुछ चीज है where it gets the nutrients from, but the nutrients it can eat up. pH कैसे maintain होगा? So for that we use a carbon dioxide incubator. इसमें से carbon dioxide उस incubator में घुसेगा. Incubator is just like a fridge जो 30 डिग्री पे रखा है. ठीक है, जहाँ पर cells the temperature at which the cells will survive. So it's just a fridge जिसके अंदर एक carbon dioxide का और एक पाइप घुसा है. पानी है, carbon dioxide है, it will maintain the pH to 7.4. अभी कैसे मेंटेन होगा? That I can do with the amount of CO2 I am supplying. Okay, so this is a practical application of what I have done from a basic experiment. Okay, if you want to see, अभी universal indicator तो घर पे नहीं होगा, so you can do something.
Yeah, what happens if people want to do this at home, they don't have universal indicator.
Exactly.
Is there something that they can do?
Yes, I will show you some simple experiment that you can try out to see the pH changes. So what we have here is cabbage water. So red cabbage, if you like just घिस दो उसको and dissolve it in water, ठीक है, boil करो तो this thing will come out like so this is something red in color here you see. Okay, so it acts as a very good pH indicator. You can do this with a China rose, gudhan ka phool also.
We can repeat this.
Repeat this one. This one.
This, yeah. So what we can do is, do you have any other? You can do it in a glass if you want. I have nothing else.
I can do it in the test tube.
In a test tube, yes. But then you need a very small piece of CO2.
So you want to do it with the CO2?
It will work. It's
It will work, but
so let's see. Okay, let's see if we can do this with the cabbage. One sec. I will need to sit down.
But then they won't have dries at their own.
But we can just see what happens to this is cabbage.
This is cabbage water.
Cabbage water, red cabbage water. ठीक है, that is very easy. क्या हुआ पता नहीं, but first make it alkaline.
Alkaline. Okay.
One sec. Let me get this one.
Okay, so you have cabbage water. You can make it alkaline. अभी alkaline के लिए I am using sodium hydroxide. At your home you will be having baking soda or something.
Or detergent, just dish detergent.
Yeah.
Detergent.
Soap powder. I'll show you an experiment with that as well. So here, if I add this, can you see something happening? I add more, and if I swirl it, you see the pink color has turned to green. And this is actually cabbage. You try it out at home, at your home. अभी हम यहाँ पर नहीं कर रहे हैं because it takes a lot of time. You see कि copper sulfate को white करने में time लगेगा. So I have just prepared this from home. So you see, now I'll add a piece of dry ice to this. Let's see this.
Let it be.
Okay. Meanwhile, I can show you an experiment which you can try it at your home easily. So let's take some haldi. It's a normal turmeric you take in the sabzi.
Sodium hydroxide is very alkaline compared to this.
Yeah, so you do not see any change here. So doesn't mean that. Yeah. I so I first tell them कि dry carbon dioxide काम नहीं कर रहा. So because I have already told you that carbon dioxide is a weak acid, right? So it gives less number of protons, but the base that I have used is actually a strong base, that is sodium hydroxide. So that is why it is taking a bit time to react, and if it doesn't, then
add a drop of acid.
I'll add a drop of acid. Okay.
But let it be. We'll do some other experiment.
But for your case, like when you're doing it at home, it will work out very fine because the bases and the acids that you have at your home are very mild. So for the base, you can use a dishwasher, a dish detergent, or any detergent like Vim, Surf Excel, कुछ भी चलेगा. For acids, you have vinegar and neem. Okay. So eventually, I don't have anything to cut the neem. So I have taken haldi meanwhile. Here is haldi. I will dissolve it in some amount of water. Okay. Here is haldi with water. Now let me add an acid which is easily available to you. Right. Here is an acid. You must be having a chaku at your home. We do not have. So here it is. Now if you add Nimbu to it, do you see any color change?
Try adding the Nimbu to the cabbage. Now there is a color change. See, the green has become, it's gone back to purple.
Okay. So here
it's actually becoming pink.
So now in haldi, if you see, do you see any color change? Haldi actually acid. So haldi does not act on Nimbu does not act on haldi. Means acid indicator to nahi hai. But what if I add detergent to it? So I have to make a solution of detergent as well. Sodium hydroxide. Okay. So this is the normal Vim detergent that we use to wash the buttons. So
You can remove the, see, it's become pink, right?
it has become pink. So it has gone from pink to blue, then greenish sort of a thing. And then here. So I have done it with some lab chemicals. You can try it out with the Nimbu as an acid at your home and detergent as a base. Okay, so here I have is haldi. Here I have dissolved Vim liquid in water. Let's see if this is enough to change the color. It is actually not. So why is it so? Because the Vim liquid that you have is actually a mild detergent. So I told you, right? It's a bank where somebody is donating a proton, somebody is donating a hydroxide. So why do we have a pH scale here then? Because there are people, or there are acids, I would say, who are donating more number of protons and somebody is donating more number of hydroxides. So depending on that number, we have the pH scale. So if the base I have added is not able to take the proton, how will my indicator know? He could change bhi hua hai ki nahi. Now I'll add a detergent. Okay. Okay. So first, let me show you with a lab chemical. Then I make a detergent solution and show you with that. You see a color change, right? Right there. So it has turned to red. So this thing you would have observed very easily. You might have ignored. When there is a haldi ka stain on your t-shirt or something, and you wash it with a soap, it immediately turns red. So this is how a haldi can actually act as an indicator for this. Okay. So you can, yeah, this definitely works with a surf excel detergent because it is much more basic in nature. So how do you know it is much more basic? Because like things are made according to the pH. Like your soap is very mildly basic because you don't want to take your pH of your body from one, like the required to very basic, because otherwise it will cause you many skin issues. Okay. So this works by detergent that I have tried. I can show you at the end because I have many more experiments. I just want to complete them once. Okay, so this is how like you can check the pH at your home using a red cabbage, using this haldi, or as I told you, using a China rose, which is a gudal food. Okay, that also works perfectly fine as an acid indicate. So now, as I told you that we synthesize molecules which have a scaffold specific for wetland and a dye. Dye, the one I have shown you, is a one which is readily available in the market. Fluorescein, it's stable enough. अभी मार्केट में हमें कोई भी चीज मिलता है that is the one which is stable. अभी ऐसा है कि मैं फ्लोरोसिन लेने जाऊं और मैं वापस आकर चेक करूं it's not फ्लोरोसिन तो मार्केट में बिकेगा ही नहीं और बेचो मैं खरीदूंगी नहीं. Fine. So there are some dyes which are not stable. So we have to make them in lab. So I'll show you a small reaction that how we make a dye in the lab. Okay. And how difficult and entertaining the entire process is. Okay. So again, I take a test tube. So you know miscibility. So there is some. Oh yeah.
You want the zoom camera also?
Yeah, yeah. Okay. So there is something called miscibility that organic things dissolve in organic, or I would say like dissolves in like. So there's hydrophobic thing that will dissolve in a hydrophobic thing. Like you would have seen the oil does not mix with water, right?
Should we clean this out?
Yeah, yeah. I have turned off the heat.
But should we? You need the plate, right?
Yeah, I'll need it later. Okay. So it doesn't happen very. Does not mix like oil and water does not mix. Right? So similarly, we have solvents in our lab, like things which do not mix. So for this reaction, I'm not taking water. I'm taking dichloromethane because whatever comes like chemicals I have, they are not water soluble. Okay, so you have seen my case with the fluorescein here. Okay, so this does not dissolve. So this experiment is generally done in methanol, which is also water soluble. But as I told, we forgot to bring the methanol. So here I am taking DCM. I have added it. Okay. Now I'll add pyrrole to it. Okay. So this reaction is actually a beautiful natural reaction also, which I'll show you in a while. But first, let's see what happens. So you see, I have paraffin on thing. It means ऐसे खुला bottle नहीं है, जैसे पानी का bottle करते हैं. Because these are the chemicals which are very hygroscopic. Like if they take water, they won't work. Okay. And this is not how we actually deal with in the lab. So whatever I am showing you here is a demonstration. Don't think this is how we work in the lab. So all these chemicals are to be taken under nitrogen. क्योंकि ऐसे बंद करने से क्या फायदा? अगर मैं उसे खोलूंगी तो हवा तो आएगा. Right? When I am opening, it is actually gaining moisture, right? So what we do in our lab is we open such bottles in a nitrogen atmosphere. Where? Abhi क्यों nitrogen? Because nitrogen does not react. It's a very stable gas. Okay, so we do under that. So here I have pyrrole. I will take. It's already brownish. Actual pyrrole is transparent. So you see how much of a reaction it has already undergone. So I added a drop of pyrrole. So obviously there is no color change because it is just dye. Okay. So at every step I will show you under UV so that when there is a turn on under UV, you won't think कि पहले से था और दिखाया बना. So there's no response. Fine. कोई change ही नहीं है, which is expected. Now I'll add something to which it will react. So it is something called bromoacetylbromide to which it reacts. And this reaction is something which gives you a formation of porphyrin. So what porphyrin is, it actually is a structure.
You can see it.
Yeah, I am seeing. You see a color change. So this is one part of the dye molecule which has been synthesized. So it's not that easy कि बन गया. Because I have just added random amount to it, right? कुछ भी डाल दिया मैंने. But yes, since two things are mixed together, they would have reacted. They have reacted. Okay. Now I'll take a dilute amount of it because it's too concentrated. Okay. It's just I have transferred it here. I'll show you under UV again. You can see under UV again that there is no fluorescence yet. Okay, you see the same thing. Fine. I'll dilute it a bit because this is too concentrated. इसमें color ही समझ में नहीं आएगा even if there's a change. So I am taking again the DCM, the dichloromethane, and I'll dilute it. Okay, at least more transparent. I'll dilute it even further. So basically, it's just dilution. So डाल के पतला कर. I'm just diluting like you do for sugar solutions, right? So still there's no change, which is obvious. Okay. Now what I'll do is I'll add a base to it. अभी इस time पर I cannot add sodium hydroxide because it was dissolved in water. अभी इसमें dissolve ही नहीं होगा. So there's no point of doing that. So I have to add a base that has to be quick enough. So because I am adding random stuffs, randomly stuffs without measuring or anything, let's see if this works out. Otherwise, I'll have to do it again. Okay.
Pink became light orange now.
Yes. Now I'll add an acid to it. So I am adding just the fumes are थोड़ा पीछे लगा. Okay, you can see some fumes coming because again an acid-base reaction. Let us see if this is. See it. There is something doing. I have to dilute it to show you. Do you see a fluorescence?
Turn it on and off. Off. Yeah. And on. It's good. Or maybe this is good for online, but for the people in the room, just lift it up and do it.
Fine. So this is a dye formation. How we make dye. So it's not as simple because अभी मैंने क्या किया इसमें randomly डालती चली गई चीजें. I didn't even bother कुछ कम होगा कुछ ज्यादा होगा. But I don't want actually to happen this way because अभी मैं एक reaction कर रही हूँ तो it requires lot of my effort. As I told you कि ऐसे जैसे मैंने खोला चीजें, it's not how we do it because it will spoil the chemicals and we don't want कि एक बड़ा डब्बा सा I am doing one reaction, right? Eventually it costs money. So this all has to be done very precisely in a reaction vessel, which is a dry setup. So if you want to see what a dry setup looks like, go to the previous Holi wala session because that we are done from the lab. So we are showing you the exact sequence of experiments. Okay, so we ban gaya. Dye to ban gaya. Now I have to take it out of this mixture because now you see I have added pyrrole, I have added something in between, I have added acids, I have added bases. So मेरा molecule उसके सबके साथ है. I want it separate, so I have to purify it. So how do I purify it? So I'll take this thing which I had shown you. Okay, so this is in DCM. It has acid, it has base, it has some soluble things. Okay. Now you know acid and bases they dissolve in water. Fine. अभी तुम्हें लगेगा कि इसमें क्यों नहीं like sodium hydroxide क्यों नहीं डाला था मैंने because the sodium hydroxide was dissolved in water. So it would not mix. So now I'll add water to it and it again should not mix, right? So it is actually not mixing. But what I will do, अभी दिखाया मैंने पहले भी that this is not mixing, but now I am benefiting this thing. Okay. So how? Because I know that from this mixture I have something which is water soluble. So this way I can take the water, the acids, the soluble acid and bases out of it. Okay? Yeah. Repeat what again?
What is the exact step for it?
I just added water to this.
Yeah, can you call it something?
Sorry, I didn't get your question.
You used it in the last 1 minute or so.
No.
You call this procedure something. Like what is this called?
This thing. Oh, this is called extraction.
Okay, sorry.
Yeah, so this is just extraction. So what I'm doing is this purification basically. So this is the first level of purification that I can do. Okay. So Because the things which are soluble in organic solvent that I cannot take care of. But which is water soluble, at least first level of purification, so I can do it this thing. Okay. So I will dissolve it in water so that the acids and bases which were soluble can come out. Now, so this is, I am showing you how the layer forms. So what we have is a separating funnel. So it is something which has a pipe in down there. So you can control it. Okay. So now if I open that tap, this layer will be separated from the other one. So here I am showing you that in a test tube. Just to show you the proof of concept, just the concept. Okay. So this is the first level of purification. Now I have my organic layer. I evaporate it off and I get a concentrated product. Abhi kya karna hai mujhe? Now I want the organic dye which I have synthesized out of all these mixtures. Okay. For that we go to something called chromatography. Okay. So here is all what I am giving you a glimpse of the different colorful stuffs that we do, and just a brief introduction of what exactly is it. So it's not that simple things. Okay. So chromatography is something you purify based on the color. And how is that done? Based on the movement on like how a thing moves with the solvent.
You need new gloves. Gloves.
Gloves. This thing again, I should.
While you prepare for that, should we show them we'll add a drop of water to the white powder?
Sure, I can immediately show. Okay, so there is a query from Arnav only that can I add a drop of water to the white copper sulfate, the dehydrated copper sulfate, and see if the color actually changes. Okay, so I have the water here. I can add a few drops and see that if the color again goes to. So the online audience can see that wherever I am putting the drop, it goes blue. For the live audience here,
We'll just pass the tray.
okay, that's a good plan. So Arnav will pass the tray so that you can see that the drop wherever I have dropped the water molecule, it has actually turned. Okay, so let us prepare for the chromatography. So here I will take two colors. So again, I'm not doing it with the exact compounds, the dye. It's just that I'm taking again the colors. Okay. So here I have a green food color. So it's the just basic food color that we have at home. Okay. And this is a chalk, a substance which will absorb water. So let's see the green color that I have added, if it's only a green color or not.
Show them the chalk first.
Khali chalk.
Khali chalk, dikha do,
Okay.
chalk.
So see, this is the chalk. Normal white wood, blackwood chalk. Okay. Here is a green color which I have mixed. Abhi tak kuch nahi mix kiya hai. Now if I drop this, you want me to do something else?
It's fine.
Let us see if something is happening. Like if there are two colors which separate out. Okay. Can I get one more small paper?
I've turned this light on also, so now it's much better. At least much better.
So it's, yeah, so the yellow color is coming up. I think that is visible. Otherwise, once it is done, I'll pass you the chalk to the audience here. And I think the online audience, it's pretty clear that a yellow color is separating from the green one. Okay, so what I'll do is, Abhi, this was pure green color. I have not added anything. Now I'll take red and green and mix them together. ये हो जाएगा.
You show that also near this camera.
Yeah, so here is the red color. So once this one is done, I'll put the green and red together and put one more chalk to show what eventually happens. So I hope you have got a glimpse of what, like how the stuffs are actually done in a chemical laboratory, where we have all those beautiful colors. We just mix them together, not randomly, obviously, with some strategy, and yeah, that results us to give a desired compound. So here I have shown you a reaction which I know is successful. So you can see that with time, the yellow color is even more getting separated from the green one. Okay, so that's exactly how chromatography works. So again, for a detailed information, you have a giant dissection for chromatography, but just for brief. So chromatography, it works like how exactly it works is it's depending upon the solubility of a compound in the solvent. So let's say there were two colors, red, yellow and green. They had different structures, obviously, because of which they had different colors, as I have shown you initially with the compounds. That if they are different in colors, it means they have different structures, right? So if they are different structures, they will have different solubilities. थोड़ा बहुत ही difference हो, because they were both soluble in water, but they have slight difference. So अभी वो difference मुझे कैसे पता चलेगा? When I make them move. It's as simple as you have two students. अगर मैं उन्हें यहाँ से उस दीवार तक भागने के लिए बोलूँगी, so they will more or less be at a same place. मतलब कुछ seconds का फर्क होगा. But if I give them 1 किलोमीटर भाग कर आओ, then I can actually see कि वो कितना distance पर है, because I need this distance between them to observe who is moving fast, who is moving slow. So that is what we are doing here. We are giving them a surface to move on, and then I can see how good they are at moving, and that different distance, their speed is actually helping me to separate the two compounds. Okay, so here it will be very simple. Chalk ke do टुकड़े करो, the green one is the alag part and the yellow one is alag. So in lab, you have to do actually a chromatography setup where you add a stationary phase here, which is the chalk. So there you add some stationary phase here. The solvent is water. There are different solvents, and
Okay. There's a question. Naitik is asking why the yellow color moved faster than the.
Exactly, that's what I told. It is about the solubility. So the yellow means that the yellow was more soluble in water, and hence it moved very fast as that with that to green. Okay. Green was actually moving slower and yellow was faster to go आगे आगे चला गया, green पीछे पीछे आ रहा है. They both are moving because you have made them like forcefully, you have made them to participate in a race. So they both will move, but that will be depending upon their speed. So the natural property you just can't change, right?
Take it out now.
Yeah,
Take this
yeah.
chalk, we can pass it down.
So here the audience, you can see that the yellow has been separated from green very beautifully, and you can pass it. Now I'll mix the green with red and see if there's some difference. Like
Okay, meanwhile, can we ask you another question?
yeah.
When you did that organic dye thing,
Yeah.
what was the brown liquid you started with first?
Okay, so that was pyrrole actually. So yeah. So in the specific case, it was 2,4-dimethyl pyrrole. So how that reaction goes is, as it's a good question actually. I
think the question is, what is pyrrole?
Oh, pyrrole. So it's basically an organic compound, I would say. I can draw the structure and tell you at least. So here, since we have this camera, I can just switch on. Can you no.
Yeah, you draw it. You first draw it.
So it's basically a 5-membered ring which has a nitrogen and this. This is what actually a pyrrole is. So what I am taking is a 2,4-dimethyl pyrrole. Okay, so for so it is this which what I have started, and what I have got is this thing which ये चीज एक लीटर में है, to which I added this. Okay, it was actually this phenol being added to this stuff, which ultimately gave me this. Okay, so this was a pink colored thing that I got, to which I added a base, which helped. Okay, so here I had. So now I added a base to help me deprotonate this proton. Okay, then I added a base which was BF3. So I got this BF2 units which were chelated, and that is how I ended up with a fluorescein. The one without this thing was not fluorescent. Then I added this acid, it became. So this was the actual sequence of reaction which has happened. So do we have another question?
Not right now. Let's go back to your.
Okay, so again you can see that now the yellow is mixed slightly with red. Okay, so now this is something interesting actually, because two things can have a similar speed even though not equal. Okay, I know yellow moves faster than green, but red can be somewhere in between. अभी green के साथ overlap नहीं दिख रहा है because they are dark colors, but yellow के साथ you can see how to separate them out, because that eventually this problem we can eventually face with my reaction as well. जब मैं उसे column में डालूंगी दो चीजें साथ में move कर देंगी. So now what the role is, now what plays the role is the solvent. You have to change the polarity of solvent. ऐसे चीजें डालो इसमें एक चीज fast जाता है, एक चीज slow जाता है, एक चीज बहुत ही slow जाता है. So that you can make them move with different speeds, like hurdle race करा दो, sort of. ठीक है? If the one person who was running very fast on a smooth road may not be able to run very fast on a hurdle. I hope that answers the question. Okay. So we have done a lot of stuff. I have given you a brief intro of what a colorful lab is. So now I'll show you some demonstrations which are really cool. So we have a blue bottle experiment which I do in this bottle only. Are we running out of time? It's just that I have two quick experiments to show you. So this is a water bottle, simple, the water which I was using so far. Now I'll take a beaker. Isme I'll mix glucose. So this glucose is normal glucon-D that you have, but I have taken it from lab. But you can do it anyway. You won't be able to do this experiment at home. So I'll make a glucon-D solution. So if somebody is there from science background, they might be knowing that glucose is actually a reducing sugar. So that is how you get energy from the sugar. It reduces, and like there's a chain of reactions which happen and eventually give you a lot of.
Take this off.
Yeah. So you again can see, and if we can have the Purana wala chalk, so you can make out that this yellow is not that yellow which was the pure one.
Where is the chalk?
It's separated, right?
It's going somewhere. Chalk? Ah, the Purana wala chalk, yes.
So now I hope that the difference is visible. That the Purana chalk is actually yellow and the second one is reddish yellow. Because the red and yellow almost move with a similar speed, so that they just mixed up. Okay. So coming to this experiment where I have just made a glucon-D solution which will give jab bhi garmi mein kitne jata hai. Now what I will do is I add sodium hydroxide to it. So I have a solution, I use that. Okay. Now what I will do is, so this is a basic glucon-D solution. Up pina nahi. Fine. To the dusra beaker, I'll add something known as methylene blue. And methylene blue is actually a redox indicator. So what it will do is the redox chemistry which can happen inside this bottle. Glucon-D is a reducing sugar, I told, वो reduce करेगा. But you know that the surface, that the atmosphere has a lot of oxygen. जो भी चीजें reduce होंगी, it will again be oxidized. अभी इसमें तो मुझे कुछ नहीं दिख रहा है. So I have to have an indicator so that I can see the process which is happening in the bottle. I hope this works. So we have taken the methylene blue solution. So this is methylene blue, which I have added. Now let's see what happens. So you can see this is blue.
Keep it.
And let us keep it and see what will happen. Let's wait for a while and see what actually happens.
Take some time.
I'll make a dilute one if required.
Add some glucose.
So that's the problem that happens when you add randomly. Otherwise, these reactions work perfectly fine if you have a weighing balance and you weigh extra. Like कितना चाहिए, कितना base चाहिए, कितना glucose चाहिए. Let's see if it works out here. Otherwise, I'll add a little amount and show you. So,
It takes some time. Take some time.
can I get the other bottle? Meanwhile, I can do the other reaction. देखते थोड़ी देर नहीं होगा तो I'll add. Okay, so again I'll add sugar. Oh, sorry, glucon-D. I think there's an issue of sodium hydroxide. Yes.
Small amount of time.
So this is a different dye. So this was methylene blue, and now I am taking indigo carbon, which is another dye, and it's also a one which is an indicator for redox process. Okay. I'm not directly adding it. I make first a solution.
Very good.
Can you see the color changing immediately to green? The blue thing changed to green. Okay. Now let us see if we can see. Let's keep it for a while. Let us wait and see. So can you see, like I can feel that the green is changing to yellow. Do you feel the same?
It will take some time.
Actually, I'm seeing up to the reflection also. Meanwhile, I can repeat these. Sorry?
Should I eat the water? We have lots of we can do the milk. It's already 12:24. So.
Okay,
Somebody said now the green has become very light.
Very
Light in shape.
yes. So it's actually changing its form, but I think it's too diluted to be observed. So that is why I'm making a concentrated one and this would be even faster.
It must be 24.
So we'll just find it.
Yeah, I think it will be after this.
I hope it changes the color. I have to add some more. So it has turned to green. Okay. Now, if you observe, I'll stop for a while and see. Do you see the green changing its color? The blue changed to green, and now it is switching to the other color, which I hope is visible. I don't know if it's visible on screen.
It's now yellowish, reddish yellowish.
Yes. So we'll wait for a while and see if the color changes again. So I hope the color change is visible, right? Right? It's changing from green to yellow, right? So it's almost yellow now.
Yeah, it's yellow.
Okay? So now I'll shake it again and see if it changes the color. Now it's again going.
Yellow.
नहीं दिख रहा है रेड जैसा.
We thought of also we need to do it.
हाँ?
We need to do it and do it later. We'll do it later. Do something else.
So what this reaction actually does is, what I hope is that there is some issue with the amount that I am adding. Otherwise, because it's the redox chemistry, so you have to understand that why it is not working. Because if there's a lot of reducing agent than the oxygen which is being supplied, so it eventually won't change the color. Okay, so that's the only thing which is happening. Otherwise, this works perfectly fine. We can show you this later sometime. So I'll show you a quick experiment with the water, with the milk.
I can throw that out. I will just go and wash it out.
Okay.
You can just take some questions if there are.
Yeah, do we have? I think we can throw it here. We don't have to wash it.
Just throw it in that bucket. There's a bucket below for trash.
Yeah, here.
Yeah, just wipe it with a tissue. It should be enough. Okay, so our original one sec. Our original blue bottle has also become very light. Okay, this has become very light, and now will you shake this once? Shake it, and it became blue again.
So that's exactly what my point is. That these reactions are actually dependent on the amount of oxygen, because it's a redox chemistry happening. There will be a reduction which will be going on by the glucose, and an oxidation which will happen because of the presence of the oxygen. So if there's an excess amount of reducing agent, which is the glucose added to it, so it will take some time to happen. So eventually this also I'm very confident that this will happen, but with some amount of oxygen when added to it. Okay. So that's again which tells you that we have to add things actually like precisely. It's not that randomly you can dump up the things. Okay, so
okay, so
here I have added milk.
okay, this is just milk.
Yes.
It's milk.
Okay, so to this we'll add some colors. The colors will be the food colors that you can easily avail from your home. Okay. So now you can see again So I'm adding drops of colors into the.
This they can do at home, right? This is just milk and food colors.
Yes. But
We put some more red or this one drop.
it's actually dissolved in this.
Tell them what you should put now.
Yeah, so I have dipped the cotton bud in a soap solution, and now I'll go and touch this. See things moving far from it. Watch for a while, and you see the things moving. So if I go to this drop, see that the other colors have started moving away from it, and that's how you make actually a rangoli or. So for you people, I think it's not visible, right? I can add more of the colors. Make a concentrated situation. Yeah.
People here can come and watch it.
Yeah.
Come and see the thing.
You can see that these colors are actually facing repulsion and they are moving far. Okay, so you can come here and see the audience. So I have added the color in the center, and when I'm taking a soap solution into it, it's just moving on. If I take a bigger thing, so it will even move further. Okay, so that's how you make color rangoli. So you can have multiple colors here, but food colors generally blue to nahi aayega, blue khana kya hi khayenge hum. So that is why these are the food colors which I have taken. You can do it even with the different poster colors and stuff. Okay, so with this we rest this session. So this is the one we were seeing, the blue bottle wala. You see it again. I've turned to colorless. Again, if I mix, it will start. It will. Okay, so the basic redox is happening. This bottle also has moved a bit towards the red side, but it's slow eventually. ज़्यादा इसमें reducification ज़्यादा लग गया.
We'll do this later.
We can do.
See,
So
there are any
basically,
more questions left. Is that the end of the experiments?
yes.
let's
So
see
we
if there are
have more or
questions.
less completed everything. Do we have any offline questions?
Let's just finish the online questions and then we'll take your
Sure,
questions
sure.
and then just stop the next thing. So, is this oxygen changing color used in color changing nail polishes?
Yes. So these are basically the dye stocks which can, so basically the colors that you have, like the nail polish and even in the hair colors you have. So these are all oxidizing colors. So that is why they actually are not permanent, because they are made to stay with the reducing agent, and then with time it actually gets oxidized and it gets washed off. So yes, actually yes, that's an oxidation process which happens.
Okay, and there are a couple of questions asking, can you please explain what happened in the blue bottle? What did you add? Why did the color become transparent?
Okay.
Can you just go through that methylene blue
Sure.
chemistry again?
Sure. So I have added a reducing glucose into it. So glucose is known as a reducing sugar, and then to make it act like a reducing agent, then I have added to it a sodium hydroxide. Okay. So now methylene blue is actually being changed to a form which gets colorless. Okay. So here you can see the reaction. Can you focus it? Here is a methylene blue structure. So methylene blue, it initially did not have a proton. So now, because of the transfer, electron transfer, which is happening between like the glucose, the oxidizing, the reducing agent, and the oxygen, this color change you can actually see. So here it is again turning to like.
This is no longer, it's only on you now, so you'll have to lift it up.
Oh, okay.
Yeah,
Sorry.
lift it up. Yeah, now you can shake it and see.
That is why. So it's basically a redox chemistry happening.
So when it is oxidized, it is blue in color. The glucose reduces it to a colorless form.
Yes.
Again, you shake it with whatever oxygen was there in the air above the liquid, it can become blue in color. That's what's happening.
Yes. So it's basically a redox process happening, reduction happening in the presence of glucose, oxidation happening in the presence of atmospheric oxygen.
Okay. All right. And is that process exothermic or endothermic? Somebody wants to know.
Oh, I don't feel it's anything like that. So it's just a room temperature reaction which does not involve which does not involve heat, I would say.
Okay, not much. Okay. All right. Are there any questions on YouTube? Let's quickly check. No questions on YouTube. So with this, let us.
Yeah, so sorry about that reaction. We would eventually do it sometime with the exact precise amounts of chemicals. But otherwise,
Let us. This is for the online audience. People here just remain here. For the online audience, thank you so much for watching us. We hope you enjoyed some of these reactions, watching them. And what's this? This is also the same, right?
no, this was that.
Oh, this was the other one. Did change color as well.
Yes. Actually, either two value.
Very diluted. Okay. Anyway, thank you so much for watching. Konika, thank you for showing us all these experiments. If you want, you can always send your questions to outreach, outreach at pifr.res.in. And remember that from now on, our sessions will be online as well as in person. So please do show up. 2 weeks from now, we will be at Prithvi Theatre on the first Sunday of April, where we will talk about molecules that influence our brain, especially the influence of psychedelic drugs and how they could be used for treating some diseases as well. That's coming up next. And in a month, we will be back here with another session of Chai and Why. Keep watching. Thank you so much and stay tuned. Okay, so what you missed, online audience, is chai or something to drink. That's what our offline audience is going to get. And we'll continue over here with some more questions that they can ask you. Okay, great.
We are ending this, right?